Alright, pre-calculus kids, here comes the last set of examples that we're going to try for this section. I have a couple things when I look at these that I want to see. First of all, if I need to put anything on hold. And the things you want to put on hold, because they don't come up until you get ready to put your points on the graph for the actual graphing of it, is if you see a negative in the front, you want to remind yourself that you want to hold on to that for later. That's going to be a flip. We talked about that in the last set of examples. The second thing that you would want to put on hold is if there was something outside the parentheses here, like a +2 or something like that, that would move it up or down. You don't have that. So the only thing you have to put on hold for now is the flip. So we're going to go right into the normal stuff we do. The period is 2 pi divided by b. Now b is whatever's in front of the x. Here's the x. So in front of it is a pi over 10. I'm just going to go horizontal with this because remember to be divided by pi over 10. Keep, change, flip. 2 pi times 10 over pi. My pi's cancel out and I'm left with an answer of 20. Well, that's kind of a strange period, but that's what it is. Amplitude is the absolute value of what's in front. Well, what's in front is a negative 0.1, so my amplitude is 0.1. Now I'm getting ready for the left, center, right. This is where sometimes it gets a little more beefy, but we can do it because we're smart. So I take whatever's inside the parentheses, pi x over 10 plus pi, and according to my reference sheet again, this is a sine. I set the left equal to negative 2 pi, the center to 0, and the right to positive 2 pi, and here I go. So this is a negative 2 pi. Set up the rest. Pi x over 10 plus pi equals 0. Pi x over 10 plus pi equals 2 pi. And I showed you the trick so we could get rid of these fractions. Ain't nobody like fractions. So I'm going to multiply. My deal is I multiply by whatever the biggest fraction is. So multiply by 10. Alright. Well, if I multiply pi x over 10 times 10 over 1, the 10's cancel. And I have just a pi x. 10 times pi is 10 pi. 10 times negative 2 pi is negative 20 pi. Alright, solve for x. Move the 10 pi to the other side. I'm going to subtract it. Well, I've got a negative 20 sitting over there. If I take 10 more negatives and put them with it, I get 30. Negative 30 pi. And then I'm going to divide by pi because I want the x by itself. So divide this side by pi, divide by this side by pi. I get x equals negative 30. If I go to the next one and do the same trick, multiply everybody by 10. You did the work right here. It's going to be pretty much the same work except this number at the end is different. So you have pi x plus 10 pi. And if I take 10 times 0, I get 0. So that's my setup for this one. Swing the 10 pi to the other side. Pi x equals a negative 10 pi. Divide by pi. X is a negative 10. Alright, last one. Same work. Pi x plus 10 pi. 10 times 2 pi is 20 pi. And if I take 10 and subtract it from 20, I have pi x on the left. I have 10 pi on the right. We can tell when we divided by pi, I got rid of the pi's. This guy is an x that's 10. And so I'm ready to set my graph up. My graph goes over here. This is going to be my negative 30. At the middle, my center is negative 10. The right's going to be positive 10. My amplitude is 0.1. Negative 0.1. 4 dashes on either side. Alright. Then I'm ready to start dotting. Before I start dotting, though, I want to make a link here for you. I want to show you something that is easy to see in this particular example. So you see how the period's 20? That period is always going to be the length from the left to the center and from the center to the right. So think about that. If I go from negative 30 to negative 10, how far have I gone? I've gone 20. If I go from negative 10 to positive 10, I've gone 20. That period tells you how far it is between these left and centers and the center and the right. And so sometimes, and we might try this in one of the future examples, sometimes you only need to calculate one of these, like this easy one that's set equal to 0, and then use that period to go left and to go right. So say I hadn't done all this work. What if I just did this much and figured out that the center is at -10? If I know that this is -10 and I say to you, well, the period's 20 and I'm going left, if I go 20 to the left of -10, I'm at -30. And if I go 20 to the right of -10, I'm at +10. I wouldn't even need to do all these two calculations for the left and the right. So there's a correlation here. In this particular one, it's easy to see. Sometimes it's nice to use, sometimes it's not as nice to use. So it just depends on the problem. But for this one, I just wanted to show you that that period is going to be very important to you, and sometimes you can use that and just one of these calculations to figure out the rest of your pieces. All right, let's get ready to dot this thing up. On the sine graph, so I'm going to my reference sheet, checking out the sine graph. Sine graph starts at the center piece right here, on the where they two cross each other, and then it goes up for my next point. All right, so this one is a flip. Remember we said it was a flip very in the beginning. Your points here at the center, it's only your top and bottom ones that switch. So instead of me being at the top point next, it's going to be over here. It's going to be down. It's a flip. Then it goes back to the axis, and then to the top point, and then back to the axis. So this one is a flipped. Instead of it having a hill first, it's going to have a valley first. And then I'm going to continue the wave going the other way. And that, my friends, is your flipped graph for 0.1 sine of pi x over 10 plus pi. All right, here comes the next one. This one they tried to trick you, and I will not do this on a test or a quiz. Here's what they really wanted to say, what they should have said if they were being nice to you. They would have said this. They would have said y equals -1/2 the sine of x over 4, and then see how this 3 is positive? They'd have put it on the back end here, +3. And so the reason why they were trying to trick you in this, because this is actually something you're going to put on hold. See how there's no parentheses involved? So this 3 is not part of that x. It's totally separate. This +3 at the end means that I'm going to move this guy up 3 in the end. And then the second thing I have to hold on to for graphing purposes is that negative. That's going to flip it. This guy has a lot going on. All right, so I've got an up 3 going on, and I've got a flip going on, but I don't worry about them until the very end. Here goes. We're going to use this formula, not that one. Period is 2 pi divided by what's in front of the x. Well, in front of the x, there's a 4 in a denominator, so really it's a 1/4. So 2 pi divided by 1/4. Keep, change, flip. 2 pi times 4 over 1. And now I've got 8 pi. Amplitude is the absolute value of what's in front. What's in front is a -1/2. Absolute value is +1/2. There's 2 of my 5 pieces down. Let's see if we can use the trick I just talked about the period of the graph, and let's just go for the center and see where it goes. So my center, I have to take whatever is, remember the +3 is an up thing, it's not like it's in parentheses. So I'm only using x over 4, and I'm setting that equal to 0. I can use my trick that we talked about, multiply both sides by 4. That means I'll have x over 4 times 4 is just an x, 0 times 4 is 0. Now, if I use the trick, and I go back to my period here, if I'm at 0 and I go left by 8 pi, where will that put me? That's going to put me at -8 pi. If I'm at 0 and I go right by 8 pi, it's going to put me at a +8 pi. And you just did that without doing much calculating at all. But let's just, because, you know, we can, I'm going to check it. We're going to check it and see if we got it right. For any doubters out there. X over 4 equals -2 pi. If I multiply both sides by 4, I'll get x equals -8 pi. Yep, that's what I wanted. If I come over here and I do the same thing, it was x over 4 equals +2 pi. When I multiply both sides by 4, x is 8 pi. And I can see I got the same thing. So it absolutely works. Now I'm ready to label this up. -8 pi. This is a 0. This is an 8 pi. I need 4 sections either way. I have an amplitude of 1/2, but I'm going to be moving everybody up by 3. Now this is going to get a little complicated, so I'm not going to put it too far off. This is going to be my 1/2. This would be my negative 1/2. Here's where it gets really dicey. Let me first go for figuring out what my new tops and bottoms are going to be. So I normally would have a point, my topmost point would be at 1/2 when I go and plot this out. But if I move up 3, if I'm at 1/2 and I add 3 to it, where am I? And you would say, you're at 3.5, winner. All right, so that's going to be my topmost point. If my next point where I would have a dot would be at the 0. If I'm at 0 and I add 3 to it, 0 plus 3 is now 3. That's going to now be my middle points. My lowest point would have been at negative 1/2. If I add 3 to a negative 1/2, I'm at 2.5. That's going to be my new low point. Okie doke. If that doesn't blow your mind, here's the next part. If I were to dot, actually maybe we should just dot it for fun. If I were to dot the sine graph would start at 0, but now it's going to be at 3. This is going to be my center point. And then it goes up for the next point, right? Sine graph, if I go to my reference sheet. But guess what? This is a flippy-do. So instead of it going there, it's going to be down here. Then it goes back to the center. And then it would have gone to the low point, but now it's at the highest point. And then back to the center. So what this guy looks like is this. Remember the sine graph, this is normally a hill, but it's going to be a valley instead because it is negative. And then I'm going to continue my dots going the other way. So center to the, it goes, this one will go up. So this one would have been a bottom guy, now it's a top guy. And then to the center, then to the bottom, then to the center. So here it is. And that, my friends, the graphing of that is the hardest part. All right. Now, if this were a test question or something like that, you might say, that was really hard, Wenner. That was a really hard one. You get partial points for all these different pieces. So if you show me the 5 pieces, that's the majority of the graph. If graphing this and moving it up is a little difficult for you, you're going to have more practice with it. But it's minimal points in the midst of getting everything else on the graph correct. So don't get yourself too worked up. We'll be fine. All right, here comes the next one. This one is, I do have one thing to put on hold for this one. Can you figure out what it is? There's no negative in the front. It's got to be this 3 in the back. This means it's going to go down 3. All right. Otherwise, I'm just graphing the way I normally graph. Now, that doesn't come in until the very end, so I don't have to worry about that quite yet. This one, the period is 2 pi divided by b. B is what's in front of the x. Ooh, I got a nice one, right? There's just a 1 there, so it is 2 pi. Amplitude is the absolute value of what's in front. Absolute value of 2 is 2. Let's see if we can do our trick with the period. Let's go for the center. I would have x minus pi, the whole set of parentheses, not the 3, the 3 is for graphing purposes, equals 0. And so then I'm going to add pi to the other side. I get x is pi. There's my center. If I use the period trick to be able to figure out the left and the right, I'm going to take 2 pi away from pi. If I'm at 1 pi and I go left by 2 pi, I'm at x equals negative pi. If I'm at pi and I go right by 2 pi, now I'm at 3 pi. If you want to check yourself, if you want to do the algebra of it, you're going to take x minus pi, set it equal to negative 2 pi, and x minus pi and set it equal to positive 2 pi, and you'll see that you get the same thing. So you can do it either way, just showing you some tricks of the trade. This one is left of negative 2 pi. Oh, I'm sorry, negative pi. I'm looking at that, but that's not it. It's negative pi. Center's at pi. Right's at 2 pi. 4 sections either way. I am going to do a down 3. So let's see. If I were normally at, my amplitude is 2. I'd be at 2, and I'd be at negative 2. And my other point would be here at 0. but I have to go down 3. So let's figure out what these new values would be. Let's see what they would be. Here goes. 2 minus 3 is negative 1. Now my top point's at negative 1. 0 minus 3 would be negative 3. This is now going to be my middle point. Negative 2 minus 3, negative 5. Here's my top, here's my middle, here's my bottom. That's how I'm going to dot this thing up. All right, let's see. This is the cosine graph not flipped. Reference sheet. Cosine graph starts at the top point. My top point's negative 1. Then it goes to the middle. For me, that's at negative 3. Then it goes to the bottom, negative 5, back to the middle, and then back to the top. So here's my right part. Continue the wave over here. Goes to the, whoop, too high. Goes to the middle. Goes to the bottom. Goes to the middle. Goes to the top. Continue your wave. And there you are. You have moved that down 3. Can we take 2 more of these crazy things? And you say, if we have to, and we do. Here it is. All right, 2 to go. This one has 2 things to put on hold. So I'm taking the negative. That means I'm going to flip it in the end. Take the plus 2. That means I'm going to go up 2 in the end. All right. Otherwise, I'm ignoring those 2 pieces while I fill in the rest of this loveliness. The period is 2 pi divided by b. Well, b's 2. That's what's in front of the x. 2's cancel. I got pi. That's my period. Amplitude is the absolute value of what's in front. Well, what's in front's a negative 5. Gives me a 5. Want to try the trick? Let's see. Center 2x, the whole parenthesis thing. Not the plus 2. That's an up 2 for later. Here it is. I have to move the pi to the other side. 2x equals a negative pi. Divide by 2. X is negative pi over 2. Now the setup would be, this one might be a little harder because it's got fractions involved and ain't nobody like fractions. But this one would be, if I took 2x plus pi, set it equal to negative 2 pi, this guy would be 2x plus pi, set it equal to positive 2 pi. You can work your way through that. But if we use the trick, if I'm at negative half pi and I go left by 1, now I'm at negative 1 and 1/2 pi. Some folks might call that negative 3 pi over 2. If I'm at negative pi over 2, negative half, and I go right by pi, now I'm at positive pi over 2. Distance of 1 pi between those. All right, again, you can do the algebra and get the same answers. Let's set up the graph. Negative 3 pi over 2. Center is at negative pi over 2. Right's at pi over 2. 4 sections. Either way. Amplitude is 5. So this is going to be a 5 and a negative 5. But everybody's moved up 2. So let's figure out where these pieces are going to be. My high point would have been at 5. 5 plus 2 is 7. High point's at 7. My middle would have been at 0, but it's up 2. Now it's at 2. And my lowest would have been at negative 5. Negative 5 plus 2 is negative 3. They are where I'm going to be dotting these. Top, middle, bottom. All right. So now I'm going to my reference sheet and I'm looking at cosine graph. Cosine graph. What do you look like? Where am I dotting you? Cosine starts at the topmost point in the middle. However, we have a flippy-do. And so this top point becomes a bottom point. So I'm going to put my dot at the lowest place. Whatever the lowest place was, which is negative 3. Then it goes to the middle. Then it would have gone to the bottom, but now it's at the top. Then back to my middle place, and then to the bottom. And so my curve, oop, I kind of missed that dot, didn't I? I'll just make the dot bigger. And then I keep going over here. Here's my middle, here's my top, here's my middle, here's my bottom. Curve me around. There it is. You have just graphed that. So you can see all these numbers do all sorts of crazy things to the graph. It's all about the labels and what those labels are. They're very important to us. Otherwise, the graphs look pretty much all the same. Last, sine and cosine example, and you say, oh, thank goodness. Awesome. Here we go. Do I have anything to put on hold? And you say, unbelievably, no, I don't have anything on hold. I don't have a negative, and I don't have a d value at the end that moves it up or down. Everything's in the parentheses. So don't have to worry about any of those things to put on hold. What I am going to do is figure out the period of the amplitude. So period's going to be 2 pi divided by b, what's in front of the x, and you say faux. There's a faux out there. All right, well, I can't reduce and talk at the same time. So 2 pi over 4 becomes a pi over 2. All right, amplitude is the absolute value of what's in front. Well, who's in front? Who's on first? I got a 2. If I try my trick, let's see how it goes. 4x plus pi over 2 equals 0. I do not like fractions, right? So we said, all right, well, so multiply by whatever that denominator is. I'm going to multiply everybody by 2. 2 times 4x is 8x. 2 times pi over 2 cancels the 2, so I got a pi. Then I'm going to move this pi to the other side. 8x equals a negative pi, and divide by 8. And I look at that and I'm like, whoa, Nelly, that's ugly. I don't think I want to use my trick on this because he's in eighths and my period's in halves. Now, if you are a fraction savvy child, then go ahead on with your big self and you can figure out what these are. But I'm going to go back to the algebra method because I just am not liking the way that this thing is setting up. So here I go. I'm going to take 4x plus pi over 2 equals negative 2 pi. This guy's going to be 4x plus pi over 2 equals a positive 2 pi. And so I need to multiply everybody by 2, my trick. 2 times 4x is 8x. 2 times pi over 2 is pi. Again, it's the same thing you get over here. This is what's different. So 2 times a negative 2 pi is negative 4 pi. And so I'm going to subtract a pi. That gives me 5. Divide by 8. I get negative 5 pi over 8. If I go to the right, do the same stuff. It's going to be 8x plus pi equals 2 times 2 pi is 4 pi. Now when I take a pi away, I'm at 3 pi's. 8x equals 3 pi's. X equals 3 pi over 8. And you have all your pieces. You're ready for the graph. This one's going to be pretty. We don't have anything that we're holding. So no flipping, no upping, no downing. We got it all right here. This guy left, negative 5 pi over 8. Center's at negative pi over 8. Right is at 3 pi over 8. And we are sectioning 4 sections either side. Top is 2, bottom is negative 2. Go to your sign reference sheet. How are you dotting this puppy? And you say, I start in the middle and then I make a hill. So I'm starting in the middle and change my color. Keep it consistent. Start in the middle, go to the top, go to the middle, go to the bottom, go to the middle. Pretty. Continue it over here. All right. So that, my friends, is how you graph sine and cosine functions. You're going to have 20 practice problems that you're going to do following the same type of thing that we've been doing together. There aren't any tricks in there. And I did include the answer key for you to reference if you need it as you're trying them. Again, if you get this foundation down on how to graph the sine and cosine functions, the other 4 trig functions, secant, cosecant, tangent, cotangent, are going to be easy peasy lemon squeezy. Is that how it goes? Something like that. All right, so email me if you have any questions, and I will talk to you soon. Bye.